Hello everybody, welcome to another stream. The webcam is back. Oh. Improve the light quality. Boom. So, last stream we got the gizmos all finished. So we got translation, rotation and scale gizmos. So, yeah, we can translate. Got a nice little infinite line which gets rendered as well when we drag the particular axes, right? We got rotation, and we also have scale as well. It also renders a nice little number, so you can see the how much it's, or what the exact number is as well. So there's still some more stuff to do for this. We might want to have like a local space transform or like option in the future, but we can do that later on. You know, I think it's in a really good place right now. It's definitely usable. I just got to plug it into some transform that we actually want to edit and see an object move around. But that's for a later date. Today we work on a because we're doing a material editor, we need to actually have a way to pick colors. Hey Pete Riggs, how's it going? Thank you, appreciate it. Yeah, it looks quite good. I'm you know, we could spend more time making it look even better, but you know, I like the way it is. It's good enough. So also functionally good. So yeah, effectively, typically people use HSV, hue saturation value, for picking colors, but this has one issue, and that is when you change the hue, the color that you currently got selected along the saturation and brightness is actually perceptually not the same brightness. So there's stuff that fixes this, and this is called OKLCH. L stands for lightness, C stands for chroma, and H stands for hue. So, you know, because you have 3 coordinates, it can be represented as a 3D volume. And what you're seeing is the representable colors in the sRGB color space. So, you know, as you drag the hue, then you see it's going across the x-axis, and that's what this is representing. Is that, and this is the chroma, so it's the y-axis in this case, and then yeah, this one's the lightness. So effectively it means we can pick a certain lightness and a particular saturation and slide our hue across, and we'll be able to change our color without changing the perceived brightness. So it should be quite powerful. The only issue is with this one though, is that you can see that the green, right, when you drag up to the green there's gaps, right? So when I drag the hue, there's no value of this perceived brightness in the sRGB color space. So we won't see anything. So you end up having to like clamp it back to probably the most maximum value or something like that for that color, which we can do. So yeah, we'll probably be doing it that way when we encounter those issues. Hey LCT, good to see you. Wait, where's the herpy? What? Where's this that you're seeing? I'm confused. Yeah, I'm not doing bad, thank you. Oh, HSV, right. Is that what comes up? I didn't give it too much attention. That's interesting. But yeah, I'm doing well. I'm doing bad, thank you. Just been working, chilling with the boy. Tomorrow I got the day off work. Just gonna be hanging around with the boy, be having some fun. Um, but yeah. Um, what else really? Um, so this might seem very complicated, this color picker, but I think I want to do one of each of these color pickers, but they're not all going to be visible at the same time. Because essentially, like all these are doing is this is a y-axis of chroma, x-axis of the lightness or the luminance, and then the problem with this bar is that it is just basically the luminance. I instead want to get rid of this bar, put another one on the side, and that'll be the hue. So you'll be able to select which plane you want the x and y axis to be, and then the z axis would just be a bar that you drag around. A bit like the hue, saturation, value color picker one, right? Like this one, right? It's got x of saturation, y of value, and then a z value representing the hue. And you can swap those around, right? So I think we'll just have three different tabs to say which kind of configuration you want to use. And yeah, so it might be similar to this, I'm not sure. Let's see how it ends up. So let's get into... So I think what we want to do is start off in the UI and make the function prototype. And then we're going to start implementing it, just make the outsides of it, and then we'll drill in to make the actual color, these color gradient things. It shouldn't be too bad to implement. So we're going to start off with a function prototype. So this is just a custom UI system. It's immediate mode. It's kind of like imgui, just not as complicated as imgui, where when you call the widget code, it will do the input stuff and the rendering at the same time. There isn't anything deferred in this system, and that's so that we can keep the whole system very simple. So this has been the design of this immediate mode UI. So we're just going to simply add a new widget. We already have popovers and split areas and tab views as well, and combo boxes apparently. So we're going to add another one. We'll call it. We might want to return a changed. So this is just so because like a boolean is kind of meaningless in and of itself, I've just got an enum, which is basically a boolean to sort of self-document what is being returned. So I don't have to put comments everywhere, right? So I've got one here called change. So if the value has changed or not changed, we'll probably want to return that. So for a color picker, you might want to explicitly pass in an ID. So typically that's a line number. And we always have a shorthand version which does that automatically. So yeah, we want an ID, we want a probably sRGB color. I don't know, because imgui uses like vector 4s, but they're all in sRGB space, isn't it? So It's a bit weird they do that. I think that's what they do. So for our game, we don't really care about representing HDR color. I think all I care about is sRGB color. So I think we can just get away with an integer 32 color value. So we'll just have the actual value here that we want to edit. And then we probably also want to pass in a style. We'll see how this goes. So yeah, value, pointed to a value and a style. This is the shorthand one, where it automatically passes in an ID. Must be a line number. So if you have it in a for loop, you should pass in, or if this is the first widget of a function, you should pass in a ID explicitly. Yeah, I hope everyone's having a good work week so far. Right, tab header. So we're just going to start off by literally making a popover with just the outline of the UI that we want it to be, and then we'll fill in all of these like things with probably just a custom shader. You could think maybe you don't have a texture, but then it won't work at any size, so custom shader will be better. So we've got a thing called a popover. Popover with an ID, explicit ID please. The position, where is it gonna? Right, so we probably need a position. So that's something I clearly missed. What was it again? Yeah, it's a float, as you would expect. So position on the screen. Oh, shoot. All right. So how big is the color picker going to be? So I don't know. Maybe we'll just hard code it. So maybe we'll do. So imagine it being like a. Maybe we can draw it quick. Be a bit of fun. So it could probably be rounded as well. So the way I imagine it is we do like a nice yes, you have your like maybe looking like that, or it might be a bit, let's draw some straight lines. So yeah, you're looking at your like little color picker thing, or your color, the thing you want to pick, and then a popover will appear. So I guess I need kind of like a button. Then when you've pressed the button, the color picker will be visible. So maybe there's actually more things we need to do beforehand, but let's just focus on this popover thing that pops up first. And the way I imagine it is we've got 3 little tabs at the bottom, right? One tab is going to be your luma or lightness. Lightness and chroma. So something like this. The next tab will be the chroma and hue, and the final tab will be the lightness and hue. So you can basically select those there and switch between them. It'll probably remember where you last was, and the last one you was on. Let's write this out. LC C/H for hue, and then L/H. Right, so you can select those different tabs, and then you'll be presented with a super lovely probably a square looking. Right, so it probably needs to be square plus. You know what? The whole thing might just be beneficial just being square. So this is where the color will go, where you can select across 2 dimensions, depending on which one you've selected. Then the third dimension will be here on the right hand side as a nice little bar that you can just drag. Right, so that's all I'm aiming for. So I guess let's just try and achieve something like this inside the popover. And then we can do these lovely textures. And then we'll do the button pop-up thing after. Microsoft likes sharp rectangles because they lack creativity, while Apple makes everything rounded. I don't know, like, you know, Microsoft did come along first, where I made the user interface. But yeah, you know, they could have evolved what they had, but typical Microsoft is they just bolt things on over the years, isn't it? What we listen to? We'll listen to a bit of Nick Johnson. Album's a jam. Highly recommend Nick Johnson. So I reckon, right, we might just do a square. Do it square, and then this and this can be the same. You know, the height of this is the width of this, kind of. And I think that will do it. So we just make it square. 400 maybe. And the alignment from the position. So imagine if you click on a button, it will probably be aligned to the bottom of this middle bottom. So my concern is we've got like a widget which creates other widgets, so the style might infect multiple things, so I've got to be careful about that. Where have I done it before? Yeah, I think we might change the API a bit later on. We might have a color picker button, then you can have a color picker pop-up thing. Yeah, we'll see about that as things go. Right, what does past Henry do? Does he use these scope things? Oh, it's like an invisible thing, isn't it? Oh, you get a rectangle back. Radio. You always have to end it. So I guess to say if the rectangle is not 0, then do all the other stuff. So we can start chopping this up a bit. So if we chop out what should I call this? Bar width. Let's do 80. Maybe that's a bit too much, but we'll see. So we can cut the bottom of from the bottom of the rectangle and get another rectangle. So this would be the bottom bar. And then we want to also chop the right hand side. And this would be our right bar area. So we've chopped this out here, so we've got this rectangle now. And then we've chopped that. So you got that area now. Cool. So from here we should be able, and the remaining one would be rectangle. The remaining space would just be the rectangle, because these cut things mutate the rectangle. I know you're a Linux guy, but Microsoft really lost touch with the UI design. They have everything duplicated now, old menus. Oh yeah. Yeah, like on Windows 11 when you right click, the new context menu doesn't have all the old things, so you can get to the old one by clicking at the bottom. Yeah. Yeah, the new thing is less useful, that's the funny thing. Alright, so along the bottom, we want to cut that rectangle on the left hand side. So all this rectangle we cut on the left evenly. Right, so we need to find an even split. So we want to call this the button width. So that is UI rectangle dims for the bottom. And we want to just take the x and divide that by 3. You will not really get whole pixels at that point, so we should probably floor it, send it to the floor. So now we simply just do a nice little for loop over these, and we basically take that bottom one and we cut left. So we'll get ourselves a new rectangle by cutting left. By the button width. and then button width. And now we finally actually put some buttons down. So effectively, if you press some button, so the button will be probably a toggle button with some kind of selected state. Yeah, toggle button with a bit of text. So the rectangle will be R. The is checked. We'll work that one out. And the string. So we probably want to use the C string version. I think that's the thing, right? Good, good, good. Yeah, I've made all these shorthand things for it. That's quite nice. Yeah, so we can just say, right, this one is... So I guess we put the strings here. Button strings array. The first one is chroma. See, it's LCH, right? So maybe do Linus and chroma. C and H, chroma and hue, and then Linus and hue. Right, and those are all the three that you need. It just depends which one we put on the X and which one we put on the Y axis. And then the one that's missing goes down the Z. Button strings, index. Sweet. Then the style. So, yeah, I don't know what to do about this. Maybe there's a... You see, there's... So the way we do it in like the UI tabbed area, I think is you... Ugh. I don't know, let's just pass in the style and see how it goes. The problem is everything's going to be using the same style as it goes in, which is a bit problematic. But maybe it's okay. Yes, if you... So this returns to you a crest. So... Wait, what does that mean for a toggle again? If the focus state is pressed. Yes, I guess it's when you click it in. That's when the value changes. I'm not sure we're fussed about that. Yeah, I'm not sure we're fussed about it. Because we've got this checked thing. So with the whole checked state, so you probably only have one of these open at a time, or maybe you can have multiple. Maybe we need to put some state on the stack somewhere. Might be useful. Let's just keep it here for now. Static, Boolean, button checked. So by default they're all 0. Alright. That'll do. Oh, did I delete it? Delete me. Cool. So I guess we could just run it and see what happens, right? Just get a little bit of so not changed. Right, so I guess let's just plug it in somewhere. I guess in the editor. We've got the editor open, right? Editor.c. We'll just plop it in here somewhere. Maybe. I need to include UI. Oh, I include UI. What's going on here? Alright. Position. Let's just put it 600, 400. Maybe the other 400 is quite big. We'll see. Alright, what's the other state? The other ones. The actual value. Right, it's a static. Color 32. Some actual color. And then we'll just pass in some style. There's like a box style that we got. We'll just pass in that. It's kind of just a global one. Cool. So I think that's all right. See what happens. Right, that's why I wasn't picking up. So hopefully we see something on the screen that's clickable. There we go. A little bit big, but we can sort that out. So, you know, when you pick on a color, you probably do want it to be this big of a thing, maybe. But yeah, these are definitely too big. So maybe we can drop it down to about maybe 300. These could be a little bit smaller. Because these are like 80 in size. So maybe we say 300. And maybe we say the bar width is half that size. Just give that a go. See what happens. Right, that's definitely a lot nicer. It's a lot more compact. These are a bit... Being toggle buttons, this is a bit weird. Oh, we don't have maybe what we want is radio buttons. These are toggle, aren't they, obviously? It's a dumb idea. Yeah, what we want is radio. Radio button, okay. A little bit inconsistent there, I think. But selected ID. Cool. That'll do it. So maybe we can make it a little bit smaller still. Oh, not you. Wait a minute. Yeah, that's a radio button like that, isn't it? But maybe we'll have to emulate it with... Yeah, maybe we'll have to emulate it with actual buttons. Okay, we'll use a toggle button, but we'll emulate it. So you probably just say like selected. So by default 0, Boolean is checked. Something like this is checked. and then you just go if. So if you actually pressed it in, and that's where returned it is pressed, isn't it? So then you'd say selected button index equal index. Should be as simple as that. There we go. So now it's changing between them like that, right? So that'd be cool. So maybe we can, yeah, maybe it's an alright size. So I guess let's fill in this rectangle here with something, and then we'll have a square area. We'll fill that in as well. Just color it. Maybe just draw something there. You know, put a box. Let's put a couple of boxes down. So we'll say UI box for the bottom. For the right rectangle with said style, and then for the remaining rectangle area, we'll put another box down just so we can see those and the sizes of those things. So they are. Right, so this is where your slider is going to go for that third dimension, and this is where the 2 dimensions will go here. We don't really have any room for like values though, like actual values, which sucks. You know, color pickers will probably benefit from some kind of values, maybe. So perhaps it could be a little bit taller and we can have another value. But I don't know what would be useful, right? L, so lightness, percentage-wise. Then chroma. Is that the most chroma goes up to is 37? Or 0.37? Yeah, apparently that chroma is just way too high. Fair enough. And then what's this value? The hue goes up to 360, okay. Right, 3 point... Oh. Right, so I don't know if we should bother with these. Oh, no, we should. We should present them here, I guess. Maybe we can just present them as 0 to 1. You know, you got lightness of 0 to 1. Chroma of 0 to 1. Hue 0 to 1, maybe. I'm not sure. Right. So where could the values go? The values could equally go on the other side at the top. Because it would be nice to see like a little swatch with the actual sort of like color you've got picked, and maybe probably the sRGB value up here or something. Yeah. Yeah, so maybe we'll actually do it the other side as well. That sounds pretty reasonable to me. So let's do a top cut. And we'll display probably the hexadecimal representation of the sRGB color. So the top bar. Hmm. And then we want to display the current color. Rectangle cut left, maybe, or we cut to the right, and that's the color that we're viewing. And this rectangle here will probably be, can I just say UI color and just, yeah, I can just display a color in here. Deref of value. Let's try that out. And then on the left hand side, I guess, or the, yeah, we probably put the sRGB color. Have you heard of the 40 game called Migaku? Probably butchered that. Yeah, I probably heard about it. I've probably seen that YouTube video where they go through the slices of 40. Um, yeah, this looks familiar. Is this still in development? Yeah, they've been building their own 4D tooling and stuff like that. Yeah, it must be like obviously some hobby thing if it's been going for that long, right? Like, you would expect a game like this to be finished in less than 15 years unless it was some hobby thing. But that's cool. I hope it comes out soon. When's it out? Is it out soon? But yeah, for those who don't know, who haven't seen the YouTube videos, effectively it's a 4D game because you can slide through the fourth dimension and the world changes. Um, yeah. Already says announced. Oh, crazy. Seeing Maya. Thank you so much for the Prime sub. Appreciate it. Appreciate your support. How are you doing? So we're going to display a bit of text here. I think I've got to put it in a temporary buffer, in all honesty. So I'm trying to print out basically a hexadecimal representation of this, but it'll be the wrong way around. So I need to do like a B swap on it, probably. I've got a B swap thing. The answer is clearly no. There's one built into Linux. But these down a library apparently. That's what. Keep it up, doing well. Just redid the folder structure for my little engine project, so it's easier to separate examples, cool, tutorials, and any other stuff I want to play around with. Cool, nice. Yeah, I see, I see. Makes sense. Yeah, I'm not doing bad, man. Not doing bad. Just yeah, it's been super busy, you know. Working and family and all sorts. But yeah, things are going very well. Um, yeah, things are going super good. We just got done doing some gizmos, so yeah, we've got a nice set of gizmos now. So ignoring the color picker, it's just in the way. You could drag it around on the plane down a particular line. I've got the rotation ones as well, and some scale ones. So happy about this. Um, yeah, my encoding stuff is nearly there. I managed to get the binary encoder stuff all code generated as well very recently. So I'm just down to adding string support to my encoder system, and then actually testing it out because I haven't tested it out yet on the material editor that we're going to be making very soon. We're getting to the point where we're actually building some nice editors. Um, yeah, I guess it's warm. Yeah, it's about 20 odd degrees. I had the room's not that big, so it keeps nice and warm. Plus, it's a new build as well, the house we live in, so it's kind of keeps the heat, which is great. I remember B-swap being a bugger. Ugh. Long is 32 on Windows. Anyway, maybe I'll just manually swap it. So the reason is, right, if you have a hex value of a color displayed out, it will technically not be in the right order. It would be back to front. The bytes would be back to front. So the two nibbles will be the pair of nibbles will be the wrong order. So if you B swap it, it will work. Um, I could have swore I had a something swap going on. Hmm. What's that shaders.txt? Right. Maybe we didn't put it in the code base in the end. So I guess it's time to do it now. So in OKLCH, we'll just chuck it in somewhere. So I guess pointer and number utilities. Just chuck it in here somewhere. So say if def Windows and Linux type of deal. By the way, if you guys don't have this in your code base, you can put programmatic breakpoints down like this. And if you did these ways, you won't get you won't be inside a function. When you break, you'll be right at that line where you do this. So highly recommend snapshotting that. But yeah, we're on a B swap. So Linux is B swap. Underscore 32. $16.64. Just get those in there quick. But yeah, sing Maya. What sort of? I guess you got a 3D engine, and what is the engine for? Have you got a game in mind that you're building? On Windows, I don't know if they're built in. I don't know. Right, so U long and U64, which is the U long long. Alright. Cool. So now with this thing we can B swap it and it'll be the right way around. So B swap R deref value. I think we need to include the B swap header. I think that's only on Linux. It's byte swap. One of them. Or I don't even need it. Maybe we could just do these underscores, but oh, there is built-in B swap. Maybe we'll just do that. Right, because I've always got to include a header, right? Including headers suck. Much better. Cool. Right, there we go, looking good. So just put a bit of text in there, so that'll just be a, put the buffer in there with the style. Then we probably also want to do the LCH values as well, but those will come later. Let's just get... Right, so I don't see anything at the top. That sucks. Why not? So we do cut top by bar width. Oh, I didn't compile it, that's why. I've done any SIMD yet, or do you plan to? Not for a while. Only if I need it really, there's no point otherwise, right? Yeah. Like, there's only, like, so what's the way of saying it? So if the entity system, I have made sure that we could possibly SIMD stuff in the future when it makes sense. So I'm always leaving the door open for potential optimizations like that. I'm not trying to overcomplicate the code. So we can always do stuff like that. But yeah. Only if it makes sense will we bother doing SIMD. Because the problem with doing SIMD is sometimes... Yeah. You know, each platform has those big old header files. You might have to I want to kind of make my own header file for each platform, so I don't include in a bunch of crap. And then also probably, yeah, it's a whole can of worms that I'd rather avoid. It's fun to code SimD. Yeah, I guess it is, but what's more fun right now, I guess, is getting stuff working, and getting features done. When we need the performance, we'll do it, I guess. Right, I put the 0 in the wrong place. Well, it wasn't shown up properly. So if we hard code in a value, for instance, so if you read it as sort of like JavaScript, as the sort of JavaScript way where they have a hash first, this would be red, this would be green, this would be blue, and this would be alpha. But in computers, it's actually the other way around in memory. This one is alpha, this one is blue, this one is green, and then this one is red. But we're B swapping it, so hopefully the way we're seeing it here should be the way that it gets represented in the UI. That's why we wanted the B swap. Yeah, so the FF comes first. There you go. It just needs to be a bit wider. So let's make it go the other way around quick. So I want to make sure those zeros are there, so that's why I put the 0 in the percent. It needs to be a bit bigger, so we're going to say 100. You know, maybe we can get away with... maybe we need 120. Alright. Maybe a bit too big, but oh well. So there's our valley that was got selected. And this is the valley that we'll actually have selected. So it's just black right now. DRF valley. Alright. So maybe we'll do some more stuff in the top bar. We'll just leave it there for now. So I guess we can have some fun and actually try and get the color picker stuff. You know, we can actually try and do some of this color picker stuff. So the way I think we've got to do it is we've got to have a custom rendering solution, because you could do stuff like this with a texture, but the problem is going to be fixed sized and you'd have to pre-render it. So we just did it as a shader. It just makes sense, right? So let's just take a look at box draw for a moment, and let's just take a little gander. So we put a shape down, then we color it, and then we finish it. So what I reckon we can do is do the same, but we color it with a special color picker, whatever, and then that will just do the rendering. We'll pass that through to the renderer. So this is going to be the actual sort of rectangle, the actual color XY. The color plane, or whatever. Right. So we put our shape down. It's going to be at no offset and local space, half dims of rectangle. Then it's going to have a radius of, that's interesting, right? Maybe we will have a state style radius as well. That'd be quite cool. UI widget state default or none. Right, so we'll hopefully get a nice radius on that as well, which would be cool. But equally, that could come in from some other style parameter. Then we ditch this, and yeah, we color it. For now, we'll just do solid color just so we can see it in action. Let's just pick a red color. And then we do a finish, and then we position it in screen space at the center of the rectangle. So let's just see that in action. There we go. It's got our red here. It's got a box around it. That's because we did this box thing here, but we'll get rid of it there. So the next thing we want to do then is actually make our own custom color thing. So we've already got a few here, right? We've got color solid, color bordered, color texture of a specific UV, glyph, gradient, linear, radial, and distance. So because it's SDF based, you can do a gradient based on distance as well. It's quite a complex drawing thing, but it's quite powerful. Probably it's quite a thing to render as well. I think I might make a cached version of this that we only do when we draw the whole UI, but maybe with the SDF stuff can be used to generate textures at some point. But for now, it's just pretty powerful and pretty cool. But it does need an optimization, I think. You can basically put down shapes and do a bunch of drawing operations and join shapes together and create different shapes that get outlined and stuff. It's really powerful. So one of the color things that we're going to have the ability to do is color right. Do I want to call it color picker? Probably an LC. So we do LC. We don't really need any color at all. CH and then L. So lightness and chroma and hue, and then lightness and hue. So we just put those on there like that. It's C, so you gotta chuck a good old void in there. And all this is gonna do is add to the draw data a bunch of words that represent like some kind of enum or something. So we just say color assert, and then push on a new enum. This is in UI shared, so shared between CPU and GPU. And then in the shader, we'll just pick this up and do whatever we want with it. So picker, else, lightness, chroma and hue, lightness and hue. So we'll then we'll push on one word to the words buffer to say color picker LC, lightness and chroma. Color and hue, lightness and hue. Sorry, chroma and hue, whatever it was. Cool. So I think we actually want some more. We also just want single digit ones as well. L, C, and H, because that bar to the right hand side is just going to be a one-dimensional thing, right? So we're going to need to have those as well, which I completely forgot about, but luckily remembered now. Hey Voodoo, how you doing? So those are the two-dimensional ones, and these are the one-dimensional ones. LCH. Cool. So effectively we can, let's just get one of these in there, right? Palette. Sorry, not palette. Picker. LH. So start with that one. We're just going to put a shape down. It'll be an ABB. We'll say color in that shape with the color picker shader. Then we're going to say finish and position it on the screen. Cool. So now inside the shader, we need to add these to the switch statements. So it's probably make the shader slower, but hey, the power of flexibility. So we've got a thing called a UI render. It's just a compute shader, launches full screen. The screen is split into 16 by 16 tiles or something like this, and each tile has a list of elements to draw back to front to back, and it early outs when it hits the most opaque thing. And then it processes this sign distance field tree stored as a linear set of words, and it just processes in it's like a little virtual machine. Basically, it's got like a stack of, it's crazy. It does clipping as well. It's quite nuts. Pretty powerful though. So one of the things that it can do the shape stuff, and it pushes onto the distance stack, and then after you can color stuff. When you do the coloring, you're guaranteed to have one shape on the distance stack, so you can do stuff with it. Like when you do a border, you can get the distance and do some things with it. So these are the ones we've got to add to it, and this is where we get to do our lovely OKLCH color picker stuff, right? So all right, so we'll just start with the LC. That's one we've decided to do first. So chroma and lightness, we'll get this sort of shape here. Right. Well, the hue would change it. Yeah, the hue would change the shape. So we should see something like this. So what we're going to find is like these conversion functions. OKLCH to RGB maybe. Yeah, we want to find stuff like this basically. And get some of these in a shared header file somewhere. Oh, some matrices. Cool. We can do that. Never heard of OKLCH, but Googled it. It seems quite interesting. Reminds me of the time when I worked on Crypto FM. We had paint there, but had most basic color. All right. Gotta just help with students with basic science. Cool. Like flood filling. The line drawing algorithm. Nice. Awesome. Sounds cool. Yeah, OKLCH is pretty sweet. So we'll be able to like change, we can pick a certain lightness and a chroma, and basically just be able to change the hue, and perceptually the brightness will stay the same. So that'll be pretty sweet. Yeah, it should be pretty powerful. So yeah, we need to implement some of these conversion functions. Basically, we want to display we want to have an XY coordinate of L and C, so L meaning lightness and C meaning chroma. And we plot that, we literally just draw it in that rectangle. And while we're doing it per pixel, we convert that value into a sRGB value, or linear value, shall we say. And if it goes out of the range between 0 and 1, we simply do not render anything. And yeah, so it should be quite easy. But yeah, I'm just going to take a quick break and get another drink, and then we'll punch some of these into the C file and write some more code. Right. BRB. Right, welcome back everybody. So yeah, the functions that we need is a way linear to x, y, z. I forgot what the x, y, z color space is. Right, x, y, z is the right, I see. So given where's the z? Right. So is x, y, z the human eye? What the human eye can see? Is that what it is? Is derived from CIE RGB in an effort to simplify the maths. Oh. All right. So the XYZ color space might be. It's probably this graph we're looking at basically, but there's a Z component to it. And all of the other coordinates, so all of the other. So this probably contains all of the color that the human eye could see, the XYZ. And then the other ones are a subset of that. Basically. That would be my understanding. So sRGB is this guy here, this rectangle here. And then linear. Wait a minute. Is that linear RGB? No, linear RGB is the same. Yeah. Radio. Okay, so what sort of functions does this thing have? OKLab to XYZ. Right, what about... Right, so OKCH. Sorry, OKLCH to OKLab. Right, so it's just essentially doing that. Okay, I remember now. Right, so we need OKLab. Right, I see. Rightio. So I guess we can punch some of these in. Is there another sort of one, maybe GLSL or something? I know there is a there was a shader toy. Maybe it was just OKLab shader toy I saw. Oh, they've already got color picker here. Shader toy. Right. So I think these conversion functions then go into probably core shared. I think I've got some sRGB stuff in here. No. Linear. Right, where is that? GPU shared? Right, it's in GPU shared at the moment. The color conversion stuff, so maybe we'll just chuck it in here. I've already got the HSV and luminance stuff, so maybe we're just going to chuck it in here somewhere. Right, finally loaded. Right, it's interesting, they've got like a hue wheel, right? But where's their conversion function? So what they use is HCL, so LCH, it's the same thing, right? I don't know. But yeah, it looks like they've got a couple of HCs. What's LMS? What's LMS? LMS color space is defined based on 3 coordinates. Right. I see. Measuring the strength of excitation of one of the 3 types of cones in the retina of the human eye. Right, that makes sense. Yeah, I think that's what the OKLab is kind of modeled after as well. Interesting. Okay. Right, so I think there's so I think we can get different conversion functions and we'll yeah, so maybe we'll do it that way. Let's check out the OKLab website. Because they have there's a bunch of functions. Shader toy. Bit scary clicking on a C++ one, to be honest. You don't know what you'll find. As you would expect, right? Run out loud. Virtual classes. Crying out loud. Alright, LCH is another, sorry, HCl color space is another one. Chromoluminance. Or, yeah, I'm not sure what the difference is between that one. Right, let's just find if there's any implementation somewhere. Or there was some conversion functions near the bottom of the page or something. I remember seeing it on one of them. Here we go. Yes. This is what we want. Right, none of this class crap. So convert from linear sRGB to OKLab. Perfect. This is what you want. So we need to implement like a cube root. I remember seeing that done somewhere. It was in GLSL. At least in templates, I'm right. Maybe there would. Whether there was, we didn't check too far. I think there was a header that I saw where it implemented the cube root, because in shaders you don't have cube root. Yeah. So I think we'll use something like this. So yeah, we don't have a cube root in shader code, so we've got to manually do it. All right, yoink. So we'll just chuck it somewhere in here. So when we got OKLab, we can go from OKLab to OKLCH. So we'll get rid of this sort of fixed PAL thing, and we'll just do this here, yeah? Just have one less function that we're not going to use. So here's the thing. ABS, PAL, sign, and voila. So there's the cube root. Cube root probably wants to be cube root float 32 like that. Maybe I should put this in my standard. Shoot. Maybe I should put it in my HCC library at some point. We'll find out. Right, so LS, is that linear? Yeah, linear sRGB, right. So we should say linear, okay. So I'm doing these sort of twos. That's my way of doing it. Maybe I should change it to from, but anyway, let's just stick with it. So it's linear to OKLab. Yeah. So I guess we'll put 3 on the end, because you might want to keep the which you'd never want to keep the alpha, I think, in this case, right? I've got to put a bunch of F's down here. Alright, so there's your color that comes in. You compute the LMS, so the small, medium, large, what it's called now. Anyway. Then you cube root it. Then do another matrix multiply to produce the OKLab values. All right. Sweet. So we want to go the other way around. We want to go from OKLab to linear sRGB. All right. So let's just knock this one out as well. You put some F's in here and all the doubles, and it is crazy. Then you cube it. So it's just the inverse of the other one. Right. Cool, so we need some more conversion functions. Just one more really. We need, so yeah, it's the same as this code was here basically, just with the cube root implementation. We need the we need this one. So it is described in that blog at the top that how you convert LAB. So L is the perceived lightness, A is how red or green the color is, and then B is how yellow or blue the color is. And this is modeled after the human eyes. Yeah. So you can convert the A and B into a chroma and hue with this maths here, right? So it's relatively simple how to do it. This one's just done it here already. So it is handling some things. So let's see what to do. So right. Okay. Lab to OKLCH. So, you know, it's simply just ATAN2 yes, it's ATAN2 BA, but then it's handling some sort of cases where it goes to a very small value if not put NaN in. And it's at degrees, interesting. And then I guess it converts them from is that converted between radians or something? Right, so typically to convert to degrees you do a times by 180 divided by pi, no, it's the other way around. Times by Yes, it seems like it's going towards... It's going to degrees. Right, they're converting it to degrees and wrapping it around. Right, so... Okay. And then they convert it back into radians when turn it back. Okay. So... Okay. Interesting. So A10 to float 32 BNA. The BNA in this case would be C dot Z C dot Y. Then the whole thing is being converted into degrees. And I guess it's handling edge cases where it overflows or something like this. But maybe it could just be clamped. Yeah, I'm not sure. So this is for H. So here. L is L. Chroma is square root of A squared and B squared. So square root there's A squared plus B squared. Okay. And then you simply return lightness, so it's C dot X, lightness, chroma, hue. Nice, why isn't that working? What's going on here? Oh, C is repeated, okay. Right, so chroma, hue. Or maybe I don't call this C, I call it cool, to make that a little bit consistent, that's good. I might as well delete these because it's quite easy to do it. Right. Yes, that's color dot X. Radio. So I guess I can just say L. Okay. So to go the other way around. So we're going to go from OKLCH to OKLAB. That will be this one here. So it's the hue. So do the radians of hue. So color.z. So this is just call it H. Then we say A. So L is equal to color X. A is equal to cosine. Well, it's C sine. I think we multiply it. So I think it's color dot y. I might be wrong on this. We'll see. We'll check it. Multiplied by the cosine of h, and then b is chroma times the sine of h. So we return LAB. So I think that's right. So they were doing, yeah, c multiplied by the cosine of 8. Yeah, it's radians. Nice. Pretty good. Nice. Right, so I think we've got all the conversion functions that we need. We just got to go ahead and start using them. That's constants. What constants? Yeah, magics. Magic numbers. But welcome, Jabra. How you doing? Welcome to the stream, sir. Yeah, magics. Can't go wrong with some magics. So yeah, we need a rectangle. So I think yeah, we're in the shade now. We're just trying to draw the color picker for L and C. So I reckon, right? Legit. Maybe we should do the GPU prefix. Like the other ones all have GPU prefixes. Alright. So, here's the thing. So when we do the texture, how do we get the rectangle? UV bottom left. How do I get my coordinates? What am I doing? Coordinate in command space. Offset in local space. And convert it into unorm. This is what I want. And then UV dims. Multiplied by UV dims. Yeah, so I get a 0 to 1 value, but in this code here. So depending on where it is in the rectangle, this will be 0 to 1 along the x or the y. And then from this, we can treat that as L and C. Lightness. Yeah, I don't know how this is going to work, to be honest. We need a maximum value or something. I don't know. Let's try it out. Let's just see what happens. So let's just pick a hue of a LCH. Let's just say you got offset dot x, offset dot y, and then a hue of 0. Let's just see what happens. We're going to go ahead and then turn that into an RGB color. Linear. Wait, what do we typically do? We need it to be in linear, isn't it? Is that right? Yeah, we need it to be in linear. So I think it's just source color. Right. So I guess we want to say color is equal to GPU OK LCH to OK lab. So we'll just do LCH like that. and then we'll convert that OKLab to color. Yeah, which would then be OKLab to linear. Then we simply just convert this linear color. Oh no, we leave it alone because the shader wants it to be in that space. So all we need to do now, so multiply source color with color. Is combining. There's source color thing what do we do with source color? Where do you come from? Right, so you'll keep repeating over source color basically. So yeah, we multiply. I've got to do something really dumb though. With the 1 alpha, so color. Maybe I can make a function for it. I don't know. Yeah, I'm probably going to be doing this quite a lot, I reckon. So I think I might just stick a 4 on the end and returns a vector 4. I'll just say color equal GPU OKLab to linear. And then we'll just return a fully opaque version. Color Y, color G, or Z, and 1. Something like that. So use the 4 version. We can just do something like that, yeah. Right, so that should be the shader that we're looking for. Let's just see what happens. Well, sorry. It should be the start of the shader that we're looking for. I'm not unsure about these values, right? These are from 0 to 1. They're unorm. We'll just see how they end up looking. This should be the start of something visual for those colors. Right, so just see white. Classic. So I don't know what's going on there. Probably because we've got the wrong enum, because it starts off as being white. Right, let's go into the color picker and have a gander. What's going on? Oh, I did LH, not LC. LC is the first one we've done. Right. So let's try LC, see what happens. There we go, something. So we've got some kind of color in here now. I'm not really changing the hue, but we could. Oh, so what's interesting about this, right, is you'll see that we might be getting some colors which are not representable in the sRGB color space. Maybe, I don't know. It does look a bit weird. So maybe we should write some of that code. So we see like how you can tell basically. If it just gets to the right place. What we want to say is if the color is out of bounds, then paint it black maybe, or we could say clamp it to the nearest 1. I don't know. So I haven't really got a function for this, but we could probably say color is HDR, something like that. So we'll just return if any of the colors are less than 0, any of the XYZ are less than 0, we'll return false. Likewise, if any are greater than 1, we'll return false. If not, we return true. So I think this would be a nice function for us. So if it is HDR color, then we can just, well, the less than 0 is not really HDR. HDR is like greater than 0. But yeah, we should probably not care about the less than. Let me remove that. That was really dumb. So we probably just want to say if return if any is greater than, return true. That's what we want. If any of color is greater than, then return true. Yep. Right, so if it's HDR, then we just set color to black. Like that. And let's see what happens. Whoops. Color XYZ, gotta swizzle that. So see what happens here. Cool, so as you can tell, it's cut out that. It's got a bit jagged though, to be honest. It's not anti-alias, it does look a bit horrible. But yeah, it doesn't look. This is L and C, isn't it? I guess it kind of looks like this, but maybe there's more room that we're missing. We can have a play around with that. But yeah, so I'm interested in this, that's for sure. We could probably do like quad intrinsics, and if you've got a quad, if quad any you could probably 50% it or something, and maybe that will work better. It'll be a bit naff, but maybe it's alright. I think you could say is HDR. There's a thing you can do on GPUs where in compute shaders you can use quad intrinsics where you can get a 2x2. Well, yeah, how do quad intrinsics work on GPU in compute again? Yeah, it would be the XY. So would it be the dispatch XY? Akraz, my friend, thank you so much for the sub, appreciate it. How have you been? Thank you for your support. I think you gotta look at HLSL docs basically, because that's where it all comes from. Right, so what is a quad in compute? Right, coordinates are right, it's part of a wave, that's what it is. Right, so get lane index divided by 4. Yeah, so it's okay. Got it. Can I use quad intrinsics to do some super hacky AA? How's my compute shader set up? So your XY is derived from what? XY. So it's going to go across the X's first, isn't it? So you've really got to swizzle. I've got to like swizzle the XY thing. I really want quad intrinsics to work, damn it. Ain't that annoying? How big's my cell size? 8. Interesting. Well, see, a quad does a row. So the quad would be the first row, which is not what you want. So I only do like a Morton swizzle on it, so Z. Well, I don't know. Should we try and deal with the Yeah, how's it going now, Kraz? What have you been up to? Right. I need a way to swizzle these. But if it's an 8x8, maybe we can use Morton code to do that. So Morton code. Yeah, so we've got a 8x8. So it'd be like this image down here. It'd be this one down here. Wait. 4. This is 8x8, isn't it? 1, 2, 3, 4. So that'd be one quad. 1, 2, 3, 4. 1, 2, 3, 4. Right. So I think if we chuck that into a Morton code, we should get the right. Chuck a thread index into Morton code. That will then mean our 0, 1, 2, 3 will be in a quad. And then we can use the quad intrinsics. Bit sketchy though. I think I've got Morton code somewhere. I've used it for the BVH, you see. Right, Morton 3D. Have we got Morton 2D? Just working and playing games. Nice. What video games have you been playing? Right, Morton is in internal shared. Alright, we need to get a... I think I need to make a Morton 2D. Too clever. Did morning code with for loop. Yeah, the magic bits method. This is a 3D one. Maybe we can just unravel this. We need this one here. Pass in a thread index and get back a 2D coordinate. The other way would be useful as well. I guess let's just flatten it out. Oh, I've not got the other way around. Interesting. Maybe we could just leave it alone. And I can always change it later. Rather than doing that comment, we just name the functions properly. Morton 2D from how many bits? It's a 32-bit integer, this will be. That's morphobia. Huh. Since I got bored with Deep Rock Galactic. Nice. Is this like a horror game or something? Yeah, sounds like it. 10 out of 10, nice. Sweet. Have you got like some friends you play it with? Signed? Huh. Weird. Get it set up. Masks. Sure, let's just put it in there like that for now. Weird GLSL syntax, let's get rid of that. Right, what crap am I looking at? Oh, comma operator. Ugh. Just so it doesn't have to put the brackets around. Ugh. Ugh. Talk about unreadable. Okay, so... Right, this ending a vector, got it. Right, this is quite the thing here. Right. Maybe we can break it into X, Y, and Z, or just X and Y. So it becomes a little bit more readable. Something like that. Then repeat. Y, 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 X, X, X. Yeah, that'll do. Cool, so that's the one we need. We can just... Yeah, we want to... Alright, let's comment this one out. Save this one for another time if I need it. Okay. So with this modern code, which in the UI shader, to make sure our quads... To make sure in a wave, so 32 threads, it goes 0, 1, 2, 3, and that is a 2 by 2 in screen space. Right? So that is a 2 by 2 quad, right? We need to take our linear dispatch local, yeah, our thread index. So we take our thread index will be 0 to 64. Yeah, 0 to 64, and it represents an 8 by 8 thing. So we can then pump this. Yeah, whatever that is. So we want to get our sort of tile. Pixel coordinate, that'd be a Morton. 2D from a 1D, that'd be thread index. So 0, 1, 2. 0, 1. Alright, here's an 8 by 8. 0, 1, 2, 3. So that's a 2 by 2. Then 4, 5, 6, 7. That's another 2 by 2. So when you use the quad intrinsics, we should be able to check a 2 by 2, and just pass data between it, basically. So it should be pretty powerful. So you have to do this in a compute shader manually, but in pixel shaders, it's automatically all set up for you. You don't have to worry about this sort of stuff. If you use pixel shaders. Alright, so let's just sort that one out. Right, so plot that there like that. We'll get thread index, tile, whatever chord. Boom. Well, it's actually called a cell. There we go. It's such a terrible name. It's a pixel coordinate in a cell. Right, hopefully this doesn't blow up the computer. Maybe it does. We'll see. But the reason why I wanted to do this is so I can do the quad any. Right, so if any of them are HDR colors and they go out of range, but not all of them, maybe we can just make it 50% transparent, and then it should just make, or I guess you could do like you could, oh, I wonder what it would do. Yeah, maybe do something a bit more smart. Yeah, Scott released some consoles just today. Cool. Sometimes with streamers in the community. Ah, interesting. Right, it's one of those streaming games. I love me a bit of Deep Rock Galactic. I've never played it. It's always looked interesting though. Deep Rock Galactic. So if you have a 2x2 pixel, right? Some of them are HDR and some of them are not HDR. If they're HDR, we want to just render black instead, right? So effectively what we would like is if it is I guess I can draw it, right? You have a super lovely, hang on a minute, super lovely 2x2, right? This is the only one with an actual color in it. Sorry, with a proper valid color in it. The rest are HDR and they go out of the range of sRGB, so we don't want to display it. So, for these guys, you should probably display 50% of whatever the value you have, right? Should that be all right? See, typically what you'd do is yeah, let's just make it display 50%. And then that way it shouldn't be so jagged, you know? So if, or we could say, right, display 50, if any is not HDR. So we want to say, is any SDR, right? So we say is, if it is HDR, make it black, but if any is SDR, just set color.alpha to 0.5. Right, so I guess this falls down to probably a less branchy code, to be honest. You probably just... no, we'll leave it like that. Right. Cool. Right. Let's try that out. Right, so if the computer blows up and the stream dies, I apologize, but we've changed GPU code, and if we've messed it up, it could mess up badly. So hopefully we're still here. Alright, we're still here. Any Boolean should work. Now I remember I removed Booleans, but maybe I didn't. What did I do? I don't know what I did. I changed how Booleans work. For crying out loud. No. Why is it doing a swap? Right, it's implemented using raw. So I don't think I've used quad intrinsics since I made that Boolean change and broke it. Yeah, I must have broke it. What's the result type then, eh? Right, what is this? It's like 9, 6. Right, return type is an int. Right, let me try and do this. See what happens. Right, I think we might have to jump in the compiler and fix something. The quest to make AA better, you know? But on those jagged lines. Right, was it just the diagonal swap? Execution scope. Right, subgroup. Yeah, okay, so that's 3. Right, so saying subgroup. Value and direction 0, so that's just the horizontal swap. Okay. Should we open the compiler and see what's going on? I crashed GPU a few times this week working on my render. Have you got an AMD card like me? Or have you got a different one? Right, see what we can fix. So in the SPIV code generation, there'll be an intrinsic for quad swap. Well, the quad any is implemented using quad swap. So basically, a Boolean SPIV, right? Return type must be a scalar or vector, floating point, int, or Boolean. So, right. That's interesting. So didn't we boil it down into doing the logical final? Right, so you swap x. So we implement the quad any or all by doing swaps. So you swap this one with your buddy across the x-axis, then you swap this one with your buddy along the y-axis, and then you swap it with your diagonal buddy. And while you're doing these swaps, you're ORing the result you get, in accumulating it into a into something. Result 1. Right, result 2. Okay. Yeah. And then you're ORing the 2 results. Right. So if it would be a logical OR and based on if it's an any or an all. Okay. So so in the abstract machine language, we make these specifically Booleans or something like this. Right. An RX 6600. You're the same as me. Funny. Did your... That's nuts. I guess you're running Manjaro or something on Linux, right? So it's definitely not a hardware problem that I've got. So in here, when we do that quad any... No, Windows here, fair play. When it brings... When you get a device lost, does it bring down your whole desktop? So quad any or all is going to... What is it going to do? It doesn't do anything? I thought it would add another instruction. I thought it would convert it with them into booleans. Oh no, but it accepts floating pointer integers. Right, gotcha. And then it returns a boolean. Oh, interesting. Right, so we can put whatever type we want in here. So rather than boolean, spivvy ID. Right, okay, gotcha. So let's have a look for the other ones where I've done boolean, like an and or something. What have I done? I think it's assigned 32. Right, what's that? This one. Spivvy.c, or is it in spivvy link? I forget these things. Spivvy link, I think. Oh, these are actual... Add instruction. Type boolean, right? Those are actual spivvy booleans. We don't use those much. Right, so there's another boolean type. Where's that? Just gotta find it. Which means assigned 32. Convert to spivvy boolean, that obviously converts to a proper spivvy ball. Yeah, I think we just do assigned 32. Maybe it's in the abstract machine language. Yeah, we just say it's assigned in. Right, so we're just gonna say it's then you've got to return a... They return ball. Right, I get what's going on. So this needs to be... So I wonder, do we have any basic types here? Right, input spivvy. Data type spivvy ID. And we should be able to get the operand data type. AML function. And the operand 1. Right, so that data type, spivvy ID. So that'd be like a... Crap. No. HCC data type AML intrinsic sign 32. That's the Boolean. Right. So we use that Boolean instead. And then when we AND it together at the end, you can't use logical OR because in SPIR land, logical OR is only for a SPIR Boolean, and SPIR Booleans are these types which are unsized. Like they've not got a size defined by the spec. So that's why we just use a sign of 32. So you can't use the logical OR. I don't know why it's not showing up. Yeah, you can't use logical OR because it's just for Boolean. What you got to use is bit OR, I think, or int. Bitwise OR. And bitwise AND. Right, so those are your things there. So that should be the fix, fingers crossed. So let's compile a new version HCC. Scripts, build, release, I guess. And we'll drop it in. Goes blank and then all comes back with send error to AMD. Not too catastrophic. Oh, okay. Interesting. Does it blue screen after a while? Because mine did that. Right, so HCC build yoink. Third party. I should have a script which does this automatically. There you go. Alright, chalk that one in there. So now the compiler's been adjusted and hopefully this works. No. Right, we definitely got the new update. Oh, we didn't pass in the proper return type. Huh? What? In. Oh, I see. The value. Quad any. Right, the value must be the same as the result type. Right, so maybe this never worked. Okay. No, I've definitely used this before. I think I changed the Boolean thing and broke it. Right, so if they're floats, it's very problematic. So you probably get the return type, stick in a temporary, convert that to a signed 32, and then yeah, it'll be something like this. AML operand data type compute unit AML function operand 1. This will be what's known as the data type. So all of them use this, except for the return type is going to be Boolean here. And the final operation so you do your swaps. So after your swap X, you need to do a yeah, I could have implemented this in user space. Might have been a bit easier. No, thankfully, awesome. Good. Yeah, maybe it would have been easier in user space. Another way of doing it. But it's kind of a lot of code as well. But yeah, so after you've swapped with the X, you need to say convert that to a int. And then and or it. Where is it in the and or? Oh, combine up. Good. Right. So I think we want another one of these. Problem is it could already be assigned 32, which is a bit annoying. So maybe we'll have a convert op. So I think it will always be an AML intrinsic type. Is there like an is int thing or so there's like you convert and right, float to U, I want like a float to S. Is there an F to S? Yeah, maybe. So you do that for the float one, and then for the it's just a bit cast for the uint. Yeah. It's annoying. The code is kind of different. You can convert it to a Boolean by doing like ands and ors. But not going to work on a float. Wrong with it. Hmm. Yeah, so what we used to do is convert it beforehand. And I used to do that in the abstract machine language, I think. Before passing it down into here, right? That's what we'll do. This code can stay simple then. Okay, so all we need to do is, the type is always going to be a boolean that comes in, so it's just a sign of 32. Right, that's all we need to care about. Then the abstract machine language generation, when we convert it from AST down into a abstract machine language, we'll go for quad any. See, how does any and all work? Well, wave active, any and all, are we using those? Because they're not doing anything special. Right, wave active any, what are you doing? Those actually have a built-in thing that work on anything, right? Convert to SPIR-V boolean. Okay. Wait a minute. Non-uniform any. Hey Kevlar, how's it going? Right, result must be a boolean, predicate must be a boolean. Right. Okay, so we convert whatever into a SPIR-V ball. By doing an equal op, is it? Yeah, by doing a not equal op. Right. Maybe we'll just do this. And then we convert it back from a boolean into whatever type. Right. This will do it. Easy peasy. Right. So I want a SPIR-V boolean. So we convert source operand. What's the source operand? Alright. What's data type mean? Right. Well, so today we're working on a color picker, believe it or not. But I wanted to get a really nice anti-aliased edge on the color picker that was not in the visible range. So as an example, can you see here these are very jagged on the web browser? To zoom in. I'm not sure if it zooms in for you, but you can see these lines are very jagged. Mine are very jagged as well when I render them. But I'm going to try and anti-alias them, and I needed to use the quad intrinsics, but then I tried to use them and in my compiler, they're broken. So I'm just having a bit of a fiddle to get that to work again. But yeah, color picker, we've been working on it today. kind of went off the rails a bit, but it's for the good of the code base, I swear. Right. So, convert the operand into a spivvy boolean, then do your thing. So this be a spivvy boolean. Right, hang on a minute. Get in there. So HCC spivvy ID boolean type. Alright. Looking good. Then this. What is that? Quad swap. So we're currently, our quad intrinsics were messed up basically. So what we have here is quad intrinsics, so 2x2 screen pixel, where if you're writing a pixel for this value, you can use a quad intrinsic to read the lane across the x-axis and the lane below. And with that, you can make intrinsics such as any or all to say yeah, you can do like, you can swap a boolean across and find out in a 2x2 have any of these got some condition on, and we're using that to tell if any of them don't have a value, and if they don't, we'll make it 50% or something like that. So it should hopefully be a nice anti-aliased edge, hopefully. So we'll see it in just a sec. Trying to figure out what is this swap value. Oh, input value, source operand. Cool. I'm a bit confused. Why is that? What's that second operand there? What we got? Bitwise or? No, we'll use the logical. Oh no. Back to logical again. Right, so the return data type is this one. Yeah, so operand 0 is the return register. So you ask for its type, that's the return data type. The result operand is this one here. So that's put in the result, that's wrong. We want to allocate a third one. A third little register. Result ID 3. Done. Oh yeah, result ID 3. So this will convert a spivvy boolean into whatever type we want the final one to be in, and that is always a, I think that's always signed 32, basically. So it just does a select there and returns you a 0 or 1 as assigned 32, based on this boolean condition. So I think that's what we need. Let me just double check it. So when we combine the things, if it's an any, we want it to OR them. If it's an AND, we want it to AND them. Our converted operand into a spivvy. Right, we're not even using this thing yet. What's going on here? So the source operand goes in here, gets converted from a number type, any int or float, and then we're saying swap that with the quad across from you on the x-axis, then or the converted operand and the result that we got from the swap into a new register result ID 1. Then we swap the y. This one will end up going into, we're swapping result ID 1 with along the y-axis and storing that in ID 2. Then ID 3 is going to actually OR 1 and 2 together. Wait, why is it going to OR 1 and 2 together? What's going on here? This just seems like a load of crap. Because if you swapped along the x once, right, and then you're sending, oh yeah, then you're sending, yeah, this is correct. Then you're sending the swaps value across the y and swapping it with the one that this one had. And then you got all the results or AND it together. Yep. And then you convert that back into a integer type. Right, that should be it. So let's compile a new compiler. Oh, HCC build. Third party HCC overwrite. Let's roll. Here we go. Fingers crossed. Oh yeah, we're in. So I think we're getting something. Let's take a screenshot. Why can't I? Oh, I got this damn popover over, so I can't tell anything. Right, so we're done with the compiler now, I think. I think it works. We'll see. Today on a nice helix trick, set buffer line multiple is really useful. What does that do? Is it said it go across multiple lines? So rather than going off the edge of the screen, it will go down on to multiple lines. Is that what it does? But yeah, so I think where's the editor? Right, so let's get rid of the color picker just for a sec. Now we can see the screenshot that we did. So let's take a look at the anti-aliasing. So we are getting, I think it's working, right? You see these are 50%ers. So within a quad, I think it's doing it right. There's a quad. But it's still looking jagged though, isn't it? Right. And then the next quad is this one here. Right. So clearly this ain't it. Maybe what we should be saying is this one becomes 50%, because what it's doing is it's making these ones kind of bright, isn't it? So why don't we instead say, right, let's do it the other way around. So if it's HDR, flat out, right. So if the color that we're trying to render, when converted from OKLCH into linear sRGB, if it goes into the HDR range, which is above 1, then we just make it black. But if any of them is SDR, No. What's the way of saying it? That's not it. That'll make it 50% for SDRs. We want to say if any of them are HDR, yeah, if this one is HDR, make it black. If any of them are HDR, then if any of them are HDR, then 50%. That still might produce some really weird results, but we can see. Right, that's definitely better. We're just, yeah, I think we're not going to be able to. I've taken another screenshot. Maybe the quad trick is not going to work out well enough. But at least we fixed a bug. And more encoded are. So here's the new screenshot. It's nicer, that's for sure. It's really not that great though. It's definitely smoother, but still a bit ugly. We could super sample it. Always a good approach, super sample. Well, so yeah, here's a prime example of what's going on. So you've got, here's a quad. You've got this one which is not which is HDR, so it's just black. This one is this one is not HDR, so it's just SDR. So we make it 50%. And so are these two here as well. We probably want to do something a little bit smarter. You could probably do a so whereas this one here is the only one which is on. Yeah, I think we need to say if it's HDR, that's the one that can be transparent, but we need to have more transparent values for it, I think. It shows your open buffers at the top of the editor, so you can easily do. Right. Interesting. That's not bad. I might try that out. Oh wow, it's quite a lot of buffers. No, you can't click it. I don't know, it's not, let me go back. Oh, GP. Right. Thank you. Yeah, maybe I'll do this. I don't know. But yeah, it's interesting. Because the way you typically do it in... How do you typically do AA with quad intrinsics to get these things? So we have a quad 2x2. So we could say, so I think let's flip it on its head. We kind of want to put it back to the way it was, I think. Where it's like, if it's HDR, it could be black, but then it won't be black if some of them are actually SDR. So at this point, I guess, if this one is the HDR one, but the rest are SDR, you want it to be probably 75% on, maybe, right? If this one is on, so if there's two of them, I guess, they're both at 50%. And then if there's three, do you really want to put all three on at 25? It doesn't make any sense, right? So, like, you only really want to color it if yeah, I think maybe quad intrinsics might not work very well with it, maybe. Because you'll get a thing where you do something like this, right? You got another quad here, and then another quad here. Say if this one has a value, and this one has a SDR value, one that actually gets displayed. This will not become a smooth 50% alpha because it's not, you know, so you'd miss stuff here and it will be kind of jagged. But maybe it's good enough. You would see it pop up every now and then though. Yeah, maybe do a thing where you just check to the left. So across the X or across the Y. And if you have one, so if it's HDR, just check, do a swap X. Do a swap X bool? Yeah, all right. Swap X boolean. So this is kind of like the code that we wrote in that in the compiler intrinsics, but it's not doing the diagonal one because we're simply just reusing that same SDR value. If we stored this into a local before doing the swap Y, it would then swap diagonal as well. But yeah, so we want to say like has SDR neighbor or something like this. So if it has an SDR neighbor, then 50% it, maybe. We'll see what happens. See if it's better or not. It's still jagged though. Problem is the blur is kind of, well, the zoom is blurry now. Right, it's definitely nicer. You're definitely getting big gaps though. You see here this one. I imagine this is a quad and this is a quad. Something like that. So we're getting a clear gap. It's looking very jagged in that regard. It's kind of alright down here though, doesn't it? Well, not really. Still jaggedy. So another way we could do it. So another way is doing it with a probably like a distance. So we've done it before with so lerp. Yeah, maybe we can just lerp between black and yeah, maybe that might be possible. So we can get the color that you've got and lerp based on how much it is outside the. So you say this HDR, we'll get the max element, max channel, or we just do luminance. Nah, max channel. So like max element of color XYZ. Then that will be over 1. So we could probably lerp. Color equals the lerp of going from color to black, the transparent black, and T. So if your max channel take 1, that'll get your value from 0 plus, right? Because it starts off at 1. So essentially what you want is, maybe I can work out what T is here. T is going to be some clamp between take 1. Now we just got to scale it a bit. I'm not sure what we'll scale it by, to be honest. So you probably want to scale it by something like 10, maybe. Let's just see how that goes. Right, so that's made it nice and soft on the edge. Bit too soft though, but it's definitely a lot. I can't see any jagged now. Yeah, maybe we should tweak it a bit. Should we do 32? Might be a bit too much. But hopefully this is what we want. Right, I can't see any jagged there. That's pretty good. Let's take a screenshot. So I've got to disable the color picker because it's a popover. It's taking up the UI input stuff if it's up. Right, so we zoom in. Look at that. Oh, ain't that good? Oh, that looks great. Yeah, it doesn't look so great here because it's not. It's a texture viewer, right? It's not a one-to-one pixel match. But obviously zoomed in, you can see it looks good. And then when we actually see it on the screen, it looks good. All right, so I think that's the anti-alias stuff there. Yeah, I had kind of a roundabout way of nailing it. I jumped into the compiler and I was like, let's fix this thing. And then we maybe didn't need it, but there we go. Nailed it. Yeah, so there's one problem with these offsets here. Then you go 0 to 1. So if we were to sort of like scale them up a bit, we might see more of a range. So I've got to get my the ranges of OKLab. Oh no, maybe that's right. Is red really all the way over there? What is mine again? L is X. Yeah, something's wrong. So the L is the X value. It goes off the screen like that. Let's remove the signed norm conversion and see what happens. I doubt I need negative values, but that's weird. Right. You can put negative values in and it does stuff. Let's scale it up a bit, see what it looks like. Right, let's animate the hue. Can we animate the hue? I've got a bit of time. I've got a bit of time. I think I got a bit of time. What was the time? Seconds. Yeah, time in seconds. Yes, we've seen it change, or it's changing down here for some reason. This one's in invalid values, by the way. So hoping to see the hue. Ah, the hue is changing now, you can see it. This is just a bit bizarre to me. Something weird is going on. Right, here we go. We're getting a different sort of shape now. But yeah, it seems like the chroma Yeah, I don't know what's going on. Oh, LCH2, okay, lab. Zero hue, that makes sense. Yeah, maybe something's wrong with these conversions. Just got to figure that one out. Wait, that looks problematic. No, it doesn't. It's B then A. Yeah, that looks sensible. Right, I guess we'll figure this out next time. So at least we made some progress on the widget. We've got a basic widget and we have something rendering in here. This is where the third dimension will go, and this is where the preview color will actually go. And here's the hexadecimal display of the value. And this will allow us to switch between different things to. It will swap the dimensions of the color picker. So you have chroma and hue in here, and lightness in this slider. So yeah, I guess in the next stream we'll just carry on and try and figure out what's going wrong inside this view, then render the rest of them, and render this guy here on the side, and then get the input selecting code working, and get a proper value being displayed here, because this is not padded out here like I expected it to be. But yeah. Right, let's find someone to raid quick. Hopefully someone is on. So our next be on Thursday. About 3 hours ago on Thursday, and then 4 hours ago on Sunday. Next Thursday there won't be a stream, but I'll keep you guys updated on that one. Right, I might just bail because I can't find anyone, I think. Okay, have a good Wednesday, guys. Hopefully see you all on Thursday.